Good morning, students. Today we are going to discuss about chapter 2, number system. First we have to know the introduction. First we have to know what is meant by data. The word data comes from the word datum. What is meant by datum? The raw facts are called datum. Raw facts means it is a fact about the people, places or some other objects. For example, name. Name equal to name, age. These are called as variables and we assign some values to these variables. Name equal to Anu, age equal to 15. These values are called as data. When we assign some values to the variables that are called as data. Next we have to know what is meant by information. The processed data are called information. When we process the data, it gives the information. For example, here name equal to Anu and age equal to 15. From this data, we have to process this data and we have to extract some information. What is that? Anu is 15 years old. This is called information. And next we have to know data representation. What is meant by data representation? Computer handles data in the form of zeros and ones. It handles the data in the form of zeros and ones. That means we already know that is a binary number. Zeros and ones are called as binary digit. For example, if we type any number or variable or special character, it converts into zeros and ones. For example, if we type 56 or some other wordings like ant, dog, whatever it is, and some special characters like numbers and special symbols, all these character sets will be converted to zeros and ones. This is called machine language. Zeros or ones are called as binary digit. In a short form, we mention that as a bit. In the binary digit, we have to take the first two letters BI and the digit we have to take the last letter T. So the binary digit, the short form of binary digit is bit. In computer, the data may be represented in different forms. The first one is bit. We already know that bit means it consists of zeros or ones. The zeros or ones are called as bit. It is represent as basic unit of data. It represents as basic unit of data. And next one is nibble. What does mean by nibble? A collection of 4 bits. A collection of 4 bits is called as nibble. For example, collection of 4 bits means 1011. The collection of 4 bits are called as nibble. And next one is byte. A collection of 8 bits. A collection of 8 bits is called as nibble. For example, 1011 1101. This collection of 8 bits are called as byte. It only considered as a basic measuring unit of memory size. The basic unit of memory size is byte. And next one is word length. What is meant by word length? For example, cat. How many characters it has? 3 characters. So, normally we will refer a cat consists of 3 letters. In computer, a CPU will process a number of bits. That is called as word length. Okay. Word length refers to a number of bits that can process by the computer CPU at a time. That is called word length. For example, 8 bits, 16 bits, 32 bits and 64 bits. A computer CPU can process 8 bits, 16 bits, 32 bits and 64 bits at a time. Present day computers uses 32 and 64 bytes. Now, in the present day computers uses only 32 and 64 bits. That means it can process 32 and 64 bits at a time. And next one, we have to know how to represent the data. How to represent the data. We already know that bit, nibble, byte. Bit means it zeros or ones. Zeros and ones is called as bit. Nibble. What is meant by nipple? A collection of 4 bits. A collection of 4 bits is called as nipple. And byte. What is meant by byte? A collection of 8 bits. A collection of 8 bits is called as byte. And this is the basic measuring unit of memory size. Whenever we measure something in a memory size, we can use this byte. And after that, kilobyte and some other measuring units we have in our computer. Kilobytes. In a primary memory or secondary memory, we can store whatever we can store in a computer that can be measured in a kilobytes, megabytes only. So after the bytes, we have kilobytes. Kilobytes means it consists of 1024 bytes. A kilobyte consists of 1024 bytes. Next one is megabyte. A megabyte means it consists of 1024 kilobytes. A megabyte consists of 1024 kilobytes. And next one is gigabyte. A gigabyte that consists of 1024 megabytes. And after that we have terabyte. Terabyte means 1024 gigabyte. It consists of 1024 gigabytes. And next one is, normally a kilo represents 1000 grams. So in mathematical term, we used 10 power 3. Normally a 1000 we can measure 1000. A 1000 can be written as 10 to the power of 3. A kilobyte that consists of 1024 bytes. So 1 kilobyte equal to 1024. So in a short form we can represent 2 to the power of 10. So we can simplify this as 2 to the cap of 10. So only here we measure a kilobyte equal to 2 to the power of 10. A megabyte is measured as 2 to the power of 20. And gigabyte is measured as 2 to the power of 30. And the terabyte is measured as 2 to the power of 40. And after that we have some other measurements, that is petabyte. Petabyte consists of 2 to the power of 50. Exabyte that consists of 2 to the power of 60. Zettabyte that consists of 2 to the power of 70. And yottabyte that consists of 2 to the power of 80. Bytes are used to represent characters in a text. Bytes are used to represent characters in a text. We can use various coding schemes to represent character sets and numbers. For example, a consists of a capital A consists of some numbers and a small a consists of some other numbers. Why we have this coding scheme means to convert into binary number system. The data whatever we can store in our computer, that can be converted into binary format. For that purpose only here we are using some coding schemes. That coding schemes means we can use that coding scheme to convert the data as unique. And the most common coding scheme is ASCII. We already know that American Standard Code for Information Interchange. In our lower classes, we had already studied this thing. The most commonly used coding system is ASCII. ASCII. That means American Standard Code for Information Interchange. This coding scheme only we are using to convert the data into binary number system. Binary values between in our ASCII coding system, the binary values between 0 to 127 that represent specific characters. It has some other specific characters. A blank space has a value of 32. A blank space has the value of 32 in the ASCII coding scheme. And the numeric value of 0 in ASCII is 48. The numeric value of 0 in ASCII value is 48. The lowercase letters consist of 0 to 120. 97 to 122. The lowercase consists of 97 to 122. That means the lowercase means smaller a. The smaller a consists of 97 and the small z consists of 122, and the uppercase letters consist of 65 to 90. The uppercase letter consists of 65 to 90. That means the capital A consists of ASCII value of 65 and that capital Z consists of 90. In our computer, we are using different type of number system to convert the data. In this, the 4 number systems. The number system is classified into 4 types. The first one is decimal, binary, octal and hexadecimal. The number system is classified into 4 types. The first one is decimal, annexed binary and octal and then hexadecimal. First one, decimal. The most commonly used number system is decimal. The most commonly used number system is decimal. In our day-to-day life, we use this decimal number system. For example, 0 to 9 numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. 0 to 9 numbers. The decimal number system consists of 0 to 9. So, in this, how many numbers we have totally? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, totally in the decimal number system, we have 10 numbers. So, the base or radix of this number system is 10. So, the base or radix of the number system is 10. Totally how many numbers we have in the decimal system is 10. So that is called as base or radix. The total number of this number system is called as base or radix. So the base of the decimal number system is 10. For example, 96 base of 10. Base means in a lower we have to write this. And the second number system is binary. We already know that binary or machine language. Binary number is called as machine language. It consists of zeros and ones. Totally, there are 2 numbers. So, the base or radix of this binary number system is 2. For example, 1011. Base of 2. Why we have to represent this base means we can easily identify whatever the number system it is. And next one, octal number system. The octal number system means it consists of 0 to 7 numbers. It consists of 0 to 7 numbers. So the base of this number is, base or radix of octal number system is 8. For example, 3, 6, 2. Base of 8. This is called as octal number system. Whenever we write the octal number system, it has the number between 0 to 7. For example, 862. That means it is not an octal number system. The octal that contains 0 to 7 numbers only. So we have to write the numbers in between 0 to 7. Next one is hexadecimal number system. The hexadecimal number system consists of 0 to 9 numbers and A to F characters. 0 to 9 numbers and A to F characters. That means A that consists of number 10. After 9 we have the number as 10 to 15. The 10 to 15 number is considered as the alphabets A to F. So the base or radix of the hexadecimal number system is 16. For example, 6F2 or 6BA of 16. It is called as hexadecimal number system. Thank you students. In the next video, I will explain you how to convert the number systems.